video, I'm going to be treating Wittig reaction, one of the reaction of alkana and alkanol. Well, in this example, I'm going to start with a typical alkana, which is butanol, 4-carbon alkana butanol. Now, Wittig reaction involve the reaction of the alkana itself with what we know as phosphonium halide. You pronounce this Y-L-I-D-E as halide. Now, the structure of this thing, this is a condensed formula of this, but the structural formula of this is phosphorus molecule at the middle, surrounded by 2 phenyl molecules. What is a phenyl? Phenyl, you know, benzene is 6,6,8,6. So a phenyl is when we remove one hydrogen from benzene that make it incomplete, so that the space created by the removal of this one hydrogen make them to bond with other groups. So phenyl is a benzene that is substituted that one of the hydrogen is despopulated. So that's a phenyl, and because of that, they have the ability to bond with other elements. So, but 3 of them are surrounding this phosphorus. Why in the front orientation, a carbon atom is attached to phosphorus with double bond. Don't forget that phosphorus is in group 5. So they have 5 outermost electron, in which only 3 is bond electron, while 1 is a lone pair. But because of that 5 outermost electron, you can still bond 5 bond. And this is the structural formula of this phosphonium halide. Now, this reaction, I'm not going to take it in terms of mechanism. I'm just going to go straight to how to form the product. This reaction will always give you an alkene product. Now, how will it happen? This phosphonium halide will dissociate into 2, which will be like this. A phenyl still attached. So when they dissociate into 2, the double bonded CH2 will dissociate such that this is how they become. Then they will show a positive charge because we have break the bond. Now, this molecule that has been dissociated from this double bonded CH2 that make it phosphonium halide, we go and attract this double bonded oxygen from this alkana. Now, when it attracts it, this oxygen will come here and join and supply those phosphorus to bond, such as what the CH2 is contributing before. So this phosphorus will not have the effect that this double bonded CH2 had actually left, because the oxygen that was attracted here can also supply, because the oxygen that was attracted here can also supply the 2 bond that was lost. So definitely it's not going to feel it. So this thing that is now formed now is called phosphonium oxide. But this has not been our organic product. This product does not concern us. So this CH2 that is dispropionated, since this oxygen has been used, this CH2 that is dispropionated will come here and come and replace the oxygen. So when it replaces the oxygen, it's going to supply this carbon chain 2 with the 2 hydrogen that the oxygen that left was actually contributing. Then you now name your compound. So if you have compound like this is now the longest chain. So this is now the 1, 2, 3, 4, 5. So because the double bond is here at the edge, you are now going to name it pentene or pent 1 in. Can you see? So the Wittig reaction, the reaction condition is phosphonium halide, which is a phosphorus that is surrounded by 3 phenyl molecules and with a double bonded carbon and 2 hydrogen. And sometimes this hydrogen might be replaced by 2 alkyl group. So if it is alkyl group, that means this chain will increase the more. But if it is just H2, so we don't have issue, because each hydrogen can be replaced by an alkyl group. You know that. But in subsequent videos, maybe I'm going to try to expatiate on that. So please kindly pause the video, then check it carefully, learn, and actually absorb this reaction. It's not hard at all. It's very, very simple, and I have made it for you. I have made it simpler for you in this video. So it's very simple. Just choose your precursory alkana or alkanol. which I used to put an I here, then react with its phosphonum halide. Just know that the phosphonum halide will dissociated from the point of double bond of the CH2. When it dissociates, it's going to now attract the oxygen that is going double here, and it's coming. So the CH2 with the double bond that is actually attached here, it's going to go and replace where it's coming from. Then making this chain become an alkene chain. So the Wittig reaction of alkanal or alkanol will always give an alkene. Thank you for watching. Please don't forget to subscribe and recommend it to friends.